In this class, we're going to talk about joint variation. What exactly do we mean by joint variation in mathematics? Joint variation describes a relationship between variables where one variable depends on two or more other variables and the relationship is directly or inversely proportional. When we talk about joint variation, it is a kind of relationship that in which we are going to have two variables being related as either being directly or inversely. You understand? Don't forget, in our previous class we've talked about direct and indirect variation. Are you getting it? So joint variation combine both direct and indirect variation. Are you getting it? So maybe if you didn't understand or you want to learn more about direct or indirect variation, you can check the description of this class. Check the link in the channel. Check the link in the first comment or the description of this video. Click on that link to watch more on that. Okay, so having understand what is meant by joint variation, let's look at some work example to help us to understand better. Okay, now I want to write this question. M varies directly as n and inversely as the square of p. If m is equals to 3, where n is equals to 2, and p is equals to 1, find m in terms of n and p. Okay, please, I want you to pay attention. This is a typical examples on joint variation, so I want you to pay attention very well. Now, if you look, let us interpret that question. M varies directly as n. Okay, now listen. M varies directly as n. Okay, and inversely as the square of p. This same m, listen, from the definition of joint variation, I told you that it is a kind of variation that describes the relationship between variables where one variable depends on two or more other variables. You understand? Where one variable depends on two or more other variables. I want you to note that statement. Okay, now back to the question. You will discover that this variable m varies directly as n and inversely as the square of p. So inversely as the square of p means 1 over p squared. Do you understand? Okay, so this is the mathematical interpretation of that statement. A variable m varies directly as n and inversely as the square of p. You understand? Okay, now if you are asked what is meant by joint variation, joint variation is a kind of variation that describes the relationship that exists between it is a kind of variation that describes the relationship that exists between where one variable depends on two or more variables. You understand? It is a kind of relationship whereby one variable, you understand? That is, you can see in the question, this variable m depends on n and it also depends on p. This kind of variation is what we call joint variation. You understand? So, and I told you that you have to be you have to understand direct variation and indirect or inverse variation. Okay, so now let us proceed with the question. Now, if m is equals to 3, if m, we are given that m, well, let me change this matter. Okay, if m is equals to 3, okay, where n is equals to 2 and p is equals to 1, we are asked to find m in terms of n and p. Find m in terms of n and p. Now look at that question. We are asked to find m in terms of n and p. That is, we are asked to express m in terms of n and p. Okay, now we cannot do that without solving the question. Okay, now before we can find m in terms of p, we need our proportionality constant. Okay, we have to introduce our proportionality constant. Now, if I want to introduce this proportionality constant, this variation sign will be changed to equals to sign. Do you understand? If at all I want to change this variation sign to an equals to sign, because you see this entity that you see here, this m is not equivalent to n over p squared. You understand? But in an attempt to help us to change this variation sign to equals to sign, we want to tell us m is equals to n over p squared. We have to introduce the proportionality constant because that will tell us the degree at which the degree of differences that exist between this single variable and the variable that it depends on, which are n and p. Do you understand? Okay, so in that case, I'm going to rewrite the equation as m is equals to kn all over p squared. Do you understand? Okay, now the next step is that I need to determine the value of k. Now, to determine the value of k, don't forget that we've been given that m is equals to 3 and n is equals to 2, while p is equals to 1 in the question. So now m is equals to 3, I'm going to have 3 here, equals to k multiplied by n is 2, so multiply by 2 all over p squared. P is 1, so I'm going to have 1 squared. Do you understand? Okay, now from this point, 1 square is 1, right? Yes. 1 times 3 is 3, so I'm going to have 2k is equals to 3, right? So to get the value of k, I'm going to divide both by 2. So k is equals to 3 over 2. Now, having gotten the value of k, we can now express m in terms of n by substituting the value of k as 3 over 2. Do you understand? Listen to the explanation again. This is m in terms of k, but we cannot give this answer. We need to find the value of the constant. You understand? The value of the proportionality constant. And we've already gotten it as what? 3 over 2. So, having gotten the value of this k as 3 over 2, to give us our full mark, you understand? If you stop here, you're not going to earn your full mark, okay? So, the expressing m in terms of n and p is m is equals to 3 over 2n all over p and all over p squared, okay? So, well, you can still proceed like this. M equals to 3n all over 2 divided by p squared. Do you understand? And you can still proceed. M is equals to 3n all over 2 multiplied by 1 over p squared. Okay, so m is equals to 3n all over 2p squared. Do you understand? Okay, so that is the solution to that question. Now let's move to another question. Okay, if p varies directly as the square of q and inversely as r, if p is equals to 36 and q is equals to 3 and r equals to 4, find p when q is 5 and r equals to 2. Okay, now let us interpret the question mathematically. P varies directly as the square of p. We have a single variable p varies directly as the square of q. So I'm going to have q squared. Do you understand? Don't forget what when we talk about joint variation, it is an attempt to describe the relationship that exists whereby one variable depends on 2 or more variables. You understand? Are you getting it? That kind of relationship is what we call the joint variation. Okay, listen, this is the basic concept. When you understand this concept, you'll be able to solve any question that comes under joint variation, and you will be able to identify the type of variation with respect to the question that you are given. Okay, so when you have a variable depending on 2 or more variables, that kind of relationship is what we call joint variation.
To watch the complete class, kindly click on the link in the description of this video or the comment section. Okay, see you in the next class.